these guys, we have to know what the general curves look like. And that's question A and B on the note sheets. We're on note sheets, section 4.4, which is on the back of page 36. And A and B are the, and C, I should say, A, B, and C are the normal curves. All the rest of the problems are variations of those, okay? You won't be successful if you don't memorize what the general curves look like, just the normal regular curves. So let's start with that. The very first one says y equals sine x. This is going to be your sine curve. Now, we are going to do this in radians because that's how big kids graph, and we are big kids. However, I need you to remember that in your circle, as you were doing problems like on the quiz, you were thinking this was 90, this was 180, this was 270, and this was 360, right? Well, how about in radians? Well, remember, 180 is the same as pi, right? So that's pi. What's 360?
2 pi.
2 pi. How about 90? 1/2 pi, which you can either write as 1/2 pi, or I prefer pi over 2, pi divided by 2. But if you like 1/2 pi better, that's fine. What about this one? 3 over 2. Because this would actually be 1.5 pi's, which is 3/2 pi. So some people write it this way. And those important angles are the ones we're going to put on here. So I'm going to put a pi over 2, and a pi, and a 3 pi over 2, and a 2 pi. Those are the important angles. If I were doing it in degrees, it would be 90, 180, 270, 360. Do you see that? Those are kind of the benchmark angles. Those are the important angles. So these are the ones we're always going to start with. Now your sine curve, and you remember this because it's one of your 12 basic functions. Remember the sine curve? How did you keep the sine and the cosine apart? Do you remember?
One went through the origin, one didn't.
The sine goes through the origin. So here is what your sine curve looks like. It's that nice little hill and valley. Notice how high up does it go? 1. How far down does it go? -1. So it's like this wave that just oscillates back and forth between 1 and -1. That's your sine curve. You need to know that shape. Now, I can't remember if I talked about this back when we did the 12 basic functions or not, but this curve actually goes on forever and ever. Did we talk about that it goes on forever and ever in both directions? So, when you draw a sine, you don't have to worry about that, because if you can draw one hill and one valley, everything else would just be a repeat of that, right? Another hill and another valley and another hill and another valley. So when you draw your sine curves, you are going to draw one period of the sine curve. And a period is the part that keeps repeating over and over again. So one hill and one valley is the period. That's it. That's all you need to draw. One hill and one valley. The length of that period is 2 pi. Now, if you've looked ahead at some of the other equations, you'll notice I've stuck numbers in there, in the equations. That's going to change the period. But you need to remember that the regular period, the period of the regular sine function is 2 pi. The amplitude of the regular sine function is 1. Any idea what that's talking about? What's the 1? How high it goes. That's exactly right. How high is that hill? It's 1 unit high. Actually, how deep is the valley? 1 unit. So the amplitude is the height of the hills or the depth of the valleys. Those will always match. However much you go up is what you're going to go down. We learned a long time ago that we can stretch our pictures, right? If we put numbers in the problem, we can stretch them. We're going to be doing that. So we will have curves that go way higher or curves that go squishier. But the standard amplitude is 1. We can change that, but the regular amplitude is 1. Got it?
Yes, ma'am.
Now we're going to draw a cosine. This will be question number B. This is a cosine. And the good news is all the labels are exactly the same. So we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. Those are exactly the same. That's 90, 180, 270, 360. Only in radians. The amplitude is still going to be 1. That isn't changing. What is different about the cosine? It doesn't start at the origin. You remember it starts up here? So it comes down like this. That is a picture of your cosine. Now it looks very strange. You need to remember that it actually keeps going. So if I do this, do you see the wave there? Do you see the hills and the valleys? It just so happens that in one trip around the circle, from 0 to 90 to 180 to 270 to 360, in one trip around the circle, this is what it looks like. So when you graph a cosine, you're going to start at the top of the hill. Instead of starting here at the origin, you're going to start at the top of the hill. The period is still 2 pi, and the amplitude is still 1. That is the period and the amplitude of the normal, regular, standard, basic cosine curve. Maya?
Why did you skip over? Why are you skipping over this one?
Why am I skipping over what?
Like the pi and the 2 pi.
No, I'm not skipping over them. That's the minimum point is a pi, and the maximum point is a 2 pi. Just like here, the maximum was a pi over 2. Maybe I'm not understanding your question. The curve does not go through, it doesn't cross the axis at all these points. It crosses every other one. So the sine crosses here and here and here. The cosine crosses here and here. Does that make sense now a little bit? Okay, now, today we're going to concentrate on sines and cosines, but I'm going to go ahead and give you the basic tangent curve so you will have it. We're going to concentrate, though, on our sines and cosines today. It's too much to do everything in one day. So here's our tangent curve. Now you're going to love this. The tangent curve is actually shorter. One period of it is shorter. The tangent curve has an asymptote at negative pi over 2 and pi over 2. A vertical asymptote at negative pi over 2 and pi over 2. And it's nothing more than a squiggly line that goes right through the origin. Now, what does that look like in terms of your 12 basic functions? It looks kind of like a cubic function, doesn't it? Except a cubic function doesn't have asymptotes. This one does. Now, why does the tangent have asymptotes? I want you to think about the work we've done the last few days, you guys. Listen. Have we had some answers that were undefined?
Yes.
And when a function is undefined, it has an asymptote there.
That's right.
So the tangent has asymptotes here and here. Now, its period is the distance from here to here. That's a period. How far is it from -1/2 to positive? Abby, see what I mean? How far is it from -1/2 to +1/2?
About a trillion degree.
1 pi. Someone said it over there, I don't know, but the period is pi. The period of the tangent is pi. Stop, wait a minute. What was the period of the sine? 2 pi. What's the period of the cosine?
2 pi.
2 pi. What's the period of the tangent?
2 pi.
Pi. No, 1 pi, 1 pi, 1 pi. Tangent is 1 pi. Tangent is 1 pi. Sine and cosine are 2 pi. All right? What's the amplitude of the tangent curve? Now, before you blurt something out, how did we describe amplitudes? How high the waves are. How high does it go? What about the tangent? No amplitude. That's right, Bryce, because we can't name it, we can't measure it, there isn't any. The tangent does not have waves, so it doesn't have a height. It goes on forever and ever. Now, like I said, we're not going to get back to those until Tuesday, because today we're going to focus on the sines and cosines. Right now, in your notes, you should have, or on your note sheet, you should have a sine picture drawn, a cosine and a tangent. For the sine, next to it, you should have written period 2 pi, amplitude 1. For the cosine, period 2 pi, amplitude 1. For the tangent, period pi, no amplitude. Now we're going to do one of the variations. Now, I need you to think back. It's been a long time. Ron, I swear to God, if you do not turn around and pay attention, I'm going to have to do something physical.
Okay. I'm sorry.
Physically violent. It's just taller. Very good, Tim Kelly. Tim anticipated my question. A long time ago, we talked about how a number out in front of the equation impacted the equation. We graphed those things. Do you remember that this makes it twice as tall?
Oh, yes.
So a sine curve, remember, I'm going to put my labels up here. A sine curve is supposed to go up to 1 and down to -1. That's what it's supposed to do. But I put this 2 out here in front. What's it going to do now?
To 2 and
It's
-2?
going to go up to 2 and down to -2.
Okay.
So I am going to have my same hill and my same valley, but now it's stretched. The period is still 2 pi. This length is still 2 pi. Didn't change that. But now my amplitude is 2. This is day 1 of your life as a grapher of trigonometric equations. So you are out there thinking, oh my gosh, I can't do this, can't do this. Yes, you can, but not if you don't memorize the basic curves. You have to memorize your basic curves so that you know how to handle the 2. Maya, calm down.
He was right.
Now, I got wild and wacky right off the bat here, because not only did I throw in a 3, but I threw in a negative. All right, now wait a minute. I think if you're paying attention and not chatting, I think you know that now we're going to go up 3 and down 3. Just like that one went up 2 and down 2. This one's going to go up 3 and down 3. Have the same labels as we always do until we change them. How do I handle the negative? It turns it upside down. Remember, this negative turns it upside down. It reflects it across the x-axis. Okay? Now listen, guys. That means that instead of starting at the top of the hill, this is what my normal cosine looks like. Instead of starting at the top of the hill, I'm going to have to start at the bottom of the valley. So I'm going to start down here. I'm going to come up to this point, then I'm going to come up to this one, down here, and finish down here. Nobody ever has trouble graphing sines and cosines. I mean sines. Sines are easy, hill, valley. Cosines give us some problem. Remember, if you start at the bottom of the valley, you must end at the bottom of the valley.
Okay.
And halfway in between will be the top of the hill.
Okay.
So if you just connect those dots, you should be okay. What is the period of this picture? So the period, 2 pi. What is the amplitude of the picture? 3. Notice, kids, this will be something some of you will miss. Notice, Megan, notice that this is a negative 3 out here, but my amplitude is not negative. My amplitude is always a positive number. How high are these hills?
The hills are 3.
How tall are the
units.
hills? Yep.
3 units.
3. That's the amplitude. 3. All right. Now we're going to skip F and go to G.
I'll put my hand up on it.
Let's see if we can get G done.
See, jam.
Now be careful here. That number is in a different place. That number is a coefficient on X. It is not out in front, right? So it affects this exactly. And Maya, I don't know if you remember this or not, but when it's on the X, it does the opposite of what you think. This number actually divides the period. So if we are dividing by a half, we're actually going to
Multiply by 2.
multiply by 2.
Two
So
words,
your
Ron.
normal period is 2 pi. We're dividing it by a half, which is 2 pi times 2, or 4 pi. Now listen. Listen. Like Maya McLaurin said, we have now stretched our picture. It used to go from 0 to 2 pi. Now it's going to go all the way out to 4 pi. Everything's going to get doubled. So the halfway point will be 2 pi, And your labels, your other labels, will be 1 pi, 2 pi, 3 pi, 4 pi. Instead of 1/2, it got doubled. Now it's 1. Instead of 1, it's doubled, it's 2. This is doubled, so it's 3, and this is doubled, so it's 4. And why is it doubled? Because you have a coefficient on the x, and that coefficient divides the period. When you divide by 1/2, you're really timesing by 2. So everything got doubled. Now what about the height? It stays 1. We didn't do anything to it. It stays 1. So your amplitude is still 1. It's a sine curve. Where do sine curves start? The origin. So it comes up to here and down to here and down to there and stops right there. That's your sine curve.
Oh, there's one more.
The amplitude is still 1, Will, because the only way you're going to change that is to put a number here. And okay, everybody's attention. You have a packet of worksheets.
Well, no, we're talking about Precal.
Your homework,
They don't have a conflict.
it's on the website, you can get it off there, but it's the one that's called, it's in your packet, and it's called Worksheet 44 to 45, and it has graphs, you're asked to graph, okay? So this is your homework, it's not in your book, so if you want to just take your worksheet home, you can. It's just the worksheet tonight, no book. Thomas, would you, hey, stop, Thomas, would you take your book?
Yeah.